This is my public lecture about Microsoft educational tools. This lecture shows a series of programs that I wrote using Microsoft Office programs that facilitates the educational process in a university level education institution. It has different applications, one about class scheduling, the other about conference scheduling, then one about course specs generator, and an interesting one about bylaw compilation and calculation of manpower in newly established programs. And the last one is a OneNote course portfolio application. As you can see, I put the programs in different colors to show using the color the program used. Green for Excel and blue for Microsoft Office Word and purple for OneNote. The Office programs can help in streamlining professor educational activities, and I am suggesting some educational tools that can save time and effort. The main applications are scheduling and file portfolio and other things. With respect to class scheduling, we have universities used to put tables in a typical form, starting from the offered courses. We assume that this is one of our create our programs in the Faculty of Engineering at Ain Shams University for spring 2009, and these are the offered courses. Then we put the offered courses, we make up this table. It's handmade table because we have 3 groups. There are a limit of the number of students per group in the credit hour programs, and this is how the timetable looks like. But in the mainstream at that time, where we didn't have credit hour programs, we used to create a table in Arabic like this, and we use color coding. This is a timetable for my department, the Irrigation and Hydraulics department, and it shows the different subjects and the days and time slots from 1 to 5. Another table extracted from the timetable, but this time not for the courses, but for the instructors. And you can see my name here, teaching fluid mechanics and graduation project. The suggested class scheduling tool, I'm using a hypothetical institution, not at the size of my big institution. To show an example, I assume that we have only 3 instructors, 2 classrooms, and 4 working days, and we give 3 classes per day only. But we have constraints that the maximum teaching load per week is 4 days, maximum number of classrooms are 2, and the instructors have preferences when it comes the time they like to teach. And we are not allowing 2 consequent classes. These are examples of instructor preferences for the simple university here. That instructor 1 does not like early classes, and instructor 2 doesn't like late classes, and instructor 3 doesn't like midday classes. We developed this mathematical model to show us where we have classes subject to the constraints of teaching load, space availability, instructor preferences, and sequent classes 1 and 2, sequent classes 2 and 3. This is how the constraint matrix is a very sparse constraint matrix, and the numbers are diagonally because of the nature of the constraints. The beauty of using linear programming is that I can increase the number of variables to hundreds or even thousands, and the same with the number of constraints. And if I am developing a feasible problem, I can get the optimal solution because this is linear programming. And this is the results I got for instructor 1, 2, and 3. And for each instructor, there are three classes per day, and it shows here where the classes are, taking into consideration that we don't allow consequent classes. This is a solver window where you can see the objective function, and we like to minimize the objective function, and these are the constraints. It's a 0-1 integer programming, therefore it is binary here, and the rest are the constraints. And then I use simplex linear programming. Then I use an example of the Faculty of Engineering, but what you are going to see now is a big table, not the result of the previous mathematical model, but the actual table of the Faculty of Engineering to show how I use pivot table to produce important reports. I have data composed of course data, instructor data, preference data, contact hours, and I use this to compile the timetable. This is the course data where you give the course code, the title, and the number of credit hours, the number of lectures, number of tutorial, and number of lab hours. Instructor data for the code, the name of the instructor, its position in the academic hierarchy of the faculty, and where he gets his PhD, because I wanted to do some side study about some other criteria, and then where his department or her department is, and the department code and his phone number. Preference data, it's a blank sheet that should be filled by the instructor to show their preferences using 0 or 1. And then this is a table for contact hours to show us where are the lectures, the tutorials, and the labs. We compile the timetable in this form. We have several, it's a database with several columns. Each column has a title or with several fields. Then I ask the computer to use the database to create a pivot table. This is how the pivot table works. And then I use these 4 spaces here to assign where is the filter, where is the row, where is the column, and where are the values, depending on the type of information I want to present. For example, here I put the program in the filter, and I put the instructor in the row, and I put 2 fields in the column labels, the day and slot, to get a simple timetable like this. And I can count any occurrence. I use the code here as a count of code for values, and I get this timetable automatically from the database. I can also use other reports like room availability, which can be extracted using the pivot table, and I can have instructor engagement for the whole week. And for some reason, because the credit hour programs at the time where I constructed this table, there was a mainstream and I wanted to answer how many instructors are part-timers. Therefore, I prepared this table for the part-time professors. And I ask myself, is it really smart? Yes, it reduces the human error. It's easy to enter data. It produces automatic reports. It controls the format of the report. And it also satisfies the instructor preferences, and it can be used for future planning of the new programs. And thanks God, since that time, we had too many programs added to create our original few programs. The other application is invigilation assignments, which is related to the previous because it's a resource allocation problem again. We can use the same mathematical model, and we can create a series of availability constraints, and then we sort them, sort the availability constraints, because we may not find a feasible solution. Therefore, we put the instructor preferences of invigilation in the hierarchy of the academic level, so that if we obtain a non-feasible solution, we release the least the constraints at the end of the table, so that we give preference to the highly ranked faculty members. There is commercial software for everything I present regarding scheduling, and these are very good software. It is commercial and you have to pay money, and you may need training, and troubleshooting may be a problem. This is a program interface. You get color-coded table. The same thing. Here is another application. It's conference scheduling. It has a different nature. Why? Because conference programs usually contain typographical mistakes because it's done manually. The same thing with all applications, because they are done manually. And these typographical mistakes can be in timing, in misspelling of author names, and the wrong connection of title to presenter, and it can cause a lot of mishaps. But the spreadsheet solution I'm suggesting is to generate a programmed schedule that will alleviate the conference organizers from a lot of embarrassment. Date and time arithmetic is used to generate an almost error-free conference schedule that is easy to develop, maintain, and edit. At the start, we collect the accepted paper and classifying according to conference themes. Then speakers have to be allocated to the relevant sessions, because we cluster the same subject papers in the same session. The whole program should fit within the conference duration in days, and therefore we may need to have parallel sessions. And also it depends on the available room in the institution or the hotel where the conference takes place. This is an illustrative example, a small conference, similar to the small example I used for the class scheduling. And here I assume that the number of participants is 120, and they fit in a 3-day conference, and they have 2 parallel sessions, and we have 4 time slots per day, and we have 5 speakers per session. After we collect the papers, we found that we have 5 themes. We assign these numbers of papers in each theme, and the number of sessions, we divide the number of papers by 5. Use a mathematical model, 0-1 integer programming, to fit the speakers into the rooms and the days of the conference. And this is the spreadsheet solution using the solver option in Excel. And this is the solver window where I have the objective function, and I restrict the objective function has to be equal to 24. And then these are the constraints, and the second one stating that the problem solved is 0-1 integer programming, and I use the simplex linear programming software. Here I get how the themes are divided into rooms in the 3 days. And then I use a simple database where the 3 columns give me 3 numbers to make a code. 1 for the day, 1 for the session, and 1 for the order of the speaker. And then the author and the title of his speech. Then I use time and date arithmetics to design the time allocation of the speakers and the coffee break and the lunch break. And it is dynamic, of course. And then by doing that, I can come up with the automatically generated conference program where it shows the session, the time, or the time are calculated by Excel, no space for human error, the author and the title. And in this program, you see that the session, you see the lunch break, and you see the coffee break in the afternoon. Conclusions. For this particular part of the presentation, spreadsheets enable the generation of conference schedule automatically. The database functions are used to process the conference records. The date and time arithmetic is used to calculate start and finish times. The table lookup function is used to connect the database to the final schedule. They are all very famous spreadsheet tools. Also, there are commercial software for conference room scheduling software. And again, you can use, this is how it looks. And again, it is a commercial software. You have to buy it. There may be some problems with troubleshooting, and you don't have access to the code of the program, and you may need training. The next one is a different subject, is how to generate the automatic course specs. This is a requirement by the quality department in the faculty. And it starts by showing the Bloom's taxonomy. Why? Because the teacher has to understand the Bloom's taxonomy, because most of the course specs file depends on his understanding to this. Therefore, this is the Bloom's taxonomy learning, where we have low level, like remembering, understanding, and high level, like evaluating and creating. In this series of slides, I show each of the levels, starting from the bottom level, how it is defined, and I give examples, keywords, and technologies used in classroom. I'm not going to go through this. I start with remembering, then understanding, then applying, then analyzing, then evaluating, then creating, and this is the blank generator. The blank generator is a spreadsheet, and it shows the different levels, knowledge and understanding for the intended learning outcomes, intellectual skills, professional skills, general skills, and it has also section for course contents, teaching and learning methods, and assessment methods. This is the drop-down choices, because the spreadsheet is based on giving the teacher or the instructor the ability to fill the form using the drop-down choices, so that he doesn't need to look into references or to go to the tables. Therefore, for example, this is knowledge and understanding, and he has to choose from recognizing, listing, describing, identifying, retrieving, and so forth. The same thing, I'm giving an example from a private university I used to work for. It's Heliopolis University. And this is a course spec file where there is a description of the file. Then I use the drop down to choose the verb, then continue the sentence. For example, describing water problems in numbers, identifying different Egyptian water structures, because the course was about water resources engineering. Here, I use this to assign the course contents to the ILOs to create these matrices for course contents, for teaching and learning methods, and for assessment methods. And these are the matrix reports. This can be generated automatically if I fill the original form in the previous slide correctly. Then I can use simple manipulation using the cell addresses to fill these forms. The other application is a new one. It's called bylaw compilation. We have a new public university of Ain Shams University, will be in the new administrative city, and I was given the pleasure to design a program on environmental engineering and informatics. And I find that most of the work is very lengthy and time consuming, and therefore I decided to help my colleagues by creating the application I am describing now. This is how we come up with what is taught according to certain rules in the 4 years of the engineering school. They are 4 now, not in this design, not 5. Therefore, in this particular slide, you have semester 1, semester 2, 3, 4, and 5, not the whole program. What I do, I just separate or create a Word file with the course code, name, and description. 3 information. Then I convert this text. I have to be careful with the end of paragraph sign, if you know what I mean, to convert this into a table. The table will have only 3 columns with the 3 pieces of information, and this is what I get. This table is in Word. Then I convert this table into Excel, and I get this table. Again, I have only 3 columns. There I go and I have an empty table. We call it in our school the green table, which has a description of each of the courses in the study program I showed you before, but empty. Then I use this with the option of mailing and select the recipients. The recipients will be taken from the spreadsheet. Therefore, I go to the spreadsheet and I say take the recipients from there. And then I go to the 3 codes in the previous, in the green table. And then, as you can see, I say insert the course code and insert the course name, then insert the course description. After I do that, I go here and I say review results. I get different pages. Each page represents 1 course with the green table filled. Then I say edit the individual documents, and then they bring all the tables in 1 form. And this is how to reach to this format by clicking the finish and merge. Then I say put all the, I want to review all the records, then we get this. To the left hand side, you'll find the navigation where all the courses, they are in this particular example, they are about 44 courses in the 4 years, shown one after the other. It saves a lot of time and a lot of effort. But mind you, this green table is not filled. I used only 3 records, but the Microsoft Word feature saves a lot of time. The example shows only the fields in the green table. We can add the rest of the fields easily to the spreadsheet by copy and paste from the program table. By doing so, we can generate the whole program course tables, because what I did was I used only 3 fields. These are all the fields in the green table: course code, course title, credit hours, prerequisites, lecture, tutorial, laboratory hours, student workload, equivalent ECTS, course contents, activities, midterm and practical, and final percent. And this is an example where things look like inside the table. And this is how I convert the Word file with all the courses into the merge table format that will be read by the mailing function in Microsoft Office Word to create all the green tables with all fields filled. Then is another example about calculation of manpower. The same previous example, they asked us to assign professors, assistant professors, associate professors, and even teaching assistants and lecturer and demonstrators to calculate the whole manpower. And they are doing this. In order to do this, we have to look at each individual semester and see the number of courses and where they come from, because these are multidisciplinary semesters where teachers come from different specializations. Some courses are university requirements, some courses are basic science, some courses come from different disciplines of engineering, and we have two other faculties from Ain Shams University, the Faculty of Informatics and Computer and Information Science, and the Faculty of Science, because the subject of the program is Environmental Informatics program. Therefore, I'm showing this is second year, third year, and fourth year. Now, I prepare a table according to what was given to us by the faculty administration to assign for the first year the head of the program and who is teaching in the different disciplines I just mentioned, from basic sciences, electrical engineering, civil engineering, mechanical engineering, university requirements, and the faculty of computers and information science and the faculty of science. And there is some constraints regarding the number of professors and associate professors, and another constraint regarding the number of appointed and number of fully seconded faculty. These constraints are given from the Supreme Council of Universities. Therefore, this is the second year, the third year, the fourth year. But the number of students in each year, we assume it is 60, but the actual load will be a cumulative of the 4 years. Therefore, I convert this single year calculations into a cumulative one using spreadsheet. And therefore, this is the second year where the staff of the second year is added to the first year. Third year is the accumulation of what happened in first year and in second year, and also in the third year. The fourth year, which number of students will be 60 by 4, will be the compilation of the instructors with their different academic levels and the subjects they teach for the whole program that take 4 years. But in order to keep the constraints regarding the number of professors and associate professors and the number of fully seconded and appointed professors, I created a linear programming model that allows me to keep this like percentages as required. But this particular solution can be used to fill the 4 years manually, starting with every year separately, then the spreadsheet will do the compilation. If I use this solution, I will not bother myself about what will happen at the end of the 4th year when I calculate the constraints, because this is a solver window that shows that I keep the constraints within the limits stated by the Supreme Council of Universities. The last application is about course portfolio. It's a OneNote application. For those who doesn't know OneNote, it belongs to the Microsoft family, and it's an electronic version of a paper notebook where you can write down notes, thoughts, ideas, scribbles, reminders, and all kinds of other information. OneNote offers a free-form canvas where you can type, write, and draw notes in the form of text, graphics, and image. What does this has to do with the educators? Actually, this shows you that there are 3 levels. There is sections, and there is pages and sub-pages, and notebooks, of course. And this shows how it is arranged and the flexibilities I talked about of how to enter data and use icons like this, because it's all in the family of Microsoft. This is another example from the same Heliopolis University I talked about, and the same course, which is Water Resources Engineering. This is, as you can see, these are the content. This is the notebook, and these are the lectures I give, and then every lecture is a tab or a section. Here, this is lecture 2 about water pressure, and I have 3 files, 2 Word files and 1 PowerPoint presentation for the lecture. If I go to the course file and I find this icon, course specs, and then I click it, I get this. And this is the beauty of OneNote. Everything is in one place. You can have the details. You can also, if you like to know the matrix matching contents, you can see this is the contents of the course and how they match the ILOs. I can even take photographs. This is one photograph with me with my students. This is my last slide, summarizing what I had just told you, that these are a series of tools, are easy to learn and use. They can save time and effort, and more tools can be developed if you understand how they were created, and they are not difficult at all.